Welcome back to Trigonometry. This is part 4. Last time we discussed more about the unit circle and the graphs of cosine and sine. I know these videos are messy, but bear with me here. So, we found out that this marker doesn't work at all. Why am I still trying to use it? Okay, we found out that the graph of cosine looks like a wave that has a peak at 1 and then kind of moves along. And that sine has peaks that look like this, right? It's like a wave. We also learned how to convert radians to degrees and degrees to radians. In this video, we're going to be talking about special equations. So, we know this is a fact, okay? We'll derive it later, but this is a fact. So this number we'll discuss later, e to the ix is cosine of x plus I sine of x. E is a constant. We'll get into it later. Okay? E is a constant. We'll get into the specifics of it later. E to the ix is cosine of x plus I sine of x. This is in radians. Okay? So, if I do instead e to the I times x plus y, right? X plus y, x and y are angles on a right angle triangle, right? They're angles. This is then going to be cosine of x plus y plus I sine of x plus y. I is the square root of -1. Remember that, okay? But now we can split this up. It's going to be e to the ix times e to the iy, right? Distribute it, and then you can use the multiplication, right? See that? But we know what each of these are going to be. It's going to be cosine of x plus I sine of x. And we're multiplying this by cosine of y plus I sine of y. Let's go and see what this gets us. Well, double distribute cosine, cosine, cosine I, sine, I sine, cosine, I sine. Okay, so in total, we'll get cosine of x times cosine of y. We're subtracting off of this sine of x times sine of y, right? Because we have this times that I squared is going to be -1 plus 2i cosine, or no, plus I times, distribute it, cosine of x times sine of y plus, have to go down here, cosine of y times sine of x, okay? What's the point of this? Well, this is the same thing as this. So we know that cosine of x plus y plus I sine of x plus y is the same thing as this, okay? Now, if I look at the real part of this, these should be equal, shouldn't they? So I know that the cosine of x plus y is then going to be the cosine of x times the cosine of y minus sine of x times sine of y and that sine, the imaginary part of x plus y, should be the same thing as the imaginary part on this. Okay? So sine of x plus y should be cosine of x times sine of y plus cosine y times sine of x. And look at that. We now have two new equations. And we got it from this thing right here. Now, I'm going to add an annotation that allows you to skip this, hopefully, because you just want to see the formula. So, now we know that cosine of x plus y is, well, cosine x cosine y, or no. Oh, God. Cosine of... Okay, so we had two equations. Cosine of x is cosine of x, cosine y, minus sine of x, sine of y. And that sine of x plus y is the same thing as sine of x, cosine x, plus sine of y. Oh no, this is cosine y, cosine x. These are your equations. God. So, plug in y equals x, so you get cosine of x plus x, which is 2x. You get cosine of x times cosine of x, or cosine squared of x, minus sine of x, sine squared of x. Okay? Now, plug in y equals x into this, so we get sine of 2x is the same thing as, well, sine of x, cosine x, right? But that turns out to be sine of x times cosine of x plus sine of x times cosine of x, right? So you get 2 times sine of x cosine x. And there you go. Right? These are all equations that you want to memorize. Excluding y equals x, you don't need that. You don't need that. Okay? Those are equations you need to know. So let's do examples. Cosine of, well, what's pi on, say, 2? This has to be the same thing as the cosine of 2 times pi on 4, doesn't it? So this is going to be, well, let's plug it into this equation. So we get cosine squared of pi on 4 minus sine squared of pi on 4, right? That's what we get here. So, out of this we get, well, it's going to be the quantity of cosine of pi on 4 turns out to be square root of 2 on 2, squaring that, minus, well, square root of 2 on 2, squared. It's the same thing here. You can plug this into your calculator. It is correct. Out of this, we get square root of 2 on 2. Well, this is going to be 2 on 4, which is 1/2. Square root of 2. Well, we don't even need to calculate each of these. It's the same thing minus the same thing. It's going to be 0. Okay? So we know that this works for pi on 2. Because if we look at the unit circle, right? 90 degrees corresponds with pi on 2, right there. We know that cosine is the x value. This right here is 0, 1. Cosine of x is 0. If you do this for sine of the same thing, you will get 1. Because 2 times square root of 2 on 2 times square root of 2 on 2 turns out to be 1. So it's going to be 2 times square root of 2 on 2 times square root of 2 on 2. You get square root of 2 times square root of 2 on 2, which is then going to be 2 on 2, which is 1, okay? So it works. We know these equations work. So now that we have all of this, you have to do these problem questions. Number 1, just as a review of last time, what is 53 degrees in radians? Number 2, what is the cosine of 2 times pi on 2? You might know it, but come on, just for the sake of it. Number 3, what is the cosine of pi on 4 plus pi on 6? Number 4, it's going to be the cosine, the sine of the same thing, pi on 4 plus pi on 6. Number 5 is to memorize this. It's a table of your angle theta and your output cosine theta, and then your other output sine theta, okay? You should remember all of these. Pi on 6. God. Corresponds with square root of 3 on 2 and 1/2. Pi on 4 is square root of 2 on 2 and square root of 2 on 2. And pi on 3 should be 1/2 and square root of 3 on 2. Inverse of this, reverse those. And then multiples of each of these you should probably also remember. And also that pi on 2 for cosines can be 0, for sines can be 1, and for 0, it's the other way around. Then you can go around doing other ones. You can probably figure it out yourself. And there we go.